Hello everyone, and welcome to part 2 of Geometry Lesson 2.5, Algebraic Proof. We're going to take a look at some more examples where we're creating algebraic proofs, but the first example we're going to have a geometry application. So let's take a look at that. In example 3, it asks us to write a justification for each step. So they've written out the steps for us, and they've also given us a diagram. So notice we have a segment, KM, and we have point L, which is on the segment between K and M. We also have these expressions. And they want to know why I can write KM as KL plus LM. Now this is something you may recall from chapter 1. We have the part, the blue part, plus the green part, equals the total part. So we're going to think through what that justification is and then write it down. And the thing that allows me to add segments together to get a bigger segment is the segment addition postulate. Now, the next thing we need to do is we need to say, how did they get from this step to the next step? And it's important to ask yourself what changed. Well, Km turned into 5x minus 4. Where could they have gotten that from? And I see it up here in red, marked out as the length of Km. And then I see that KL turned into an x plus 3. And I see that over here in blue. KL, this part, is x plus 3 units long. And I see that LM turned into a 2x minus 1, which is the label on LM. So what they did is they took these expressions and put them into the equation for what they represent. So think through what kind of a justification that is that allows me to replace something with something that's equal to it. And that's the substitution property of equality. Next, let's see what changed for this next step. The 5x minus 4 stayed exactly the same, but this x plus 3 plus 2x minus 1 turned into 3x plus 2. What they did is they combined the like terms. X plus 2x is 3x, and 3 plus negative 1 is 2. Now notice, they didn't do things on both sides of the equation. They didn't like add something to both sides, or they didn't subtract something from both sides. So this is not a property of equality because nothing crossed the equal sign. They stayed working on one side. So we can note this in one of two ways. We can say that they combined like terms, or we can just say that they simplified the equation. Okay, now that we've established what they did in this step, let's see what changed to the next step. Notice the 5x turned into a 2x, and the 3x disappeared from here. So think about what they could have done. How can I get the 3x to this side? Well, I would subtract it from both sides. So this would be the subtraction property of equality. Now let's look at what changed between our current step and the next step. The minus 4 disappeared, and the 2 turns into a 6. So think about what they could have done on both sides of the equation, and I think they added 4. So this would be the addition property of equality. Now, finally, in the last step, the 2 disappears. It was 2x, now it turns into a plain x. So they must have divided both sides by 2, because 6 divided by 2 is 3. So our final step is the division property of equality. Okay, so the key with these, at the very beginning you say, how can I get this from the diagram? And then say what changed between each step, and try and identify what they did. And it sometimes helps to think through what you would do to finish solving an equation. Okay, we're going to move on to some properties of congruence now. They're very similar to properties of equality, The only difference between properties of equality and properties of a congruence is that these have congruent symbols. So we only have 3 of them. The reflexive property says that if a figure is congruent to a figure, then that's all we need to write. So EF is congruent to EF. And again, this is something that doesn't seem like it's useful, but surprisingly, we use it more often than you would think. The symmetric property says that if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1, and you're allowed to switch the sides of the congruence symbol. And the transitive property is if PQ is congruent to RS and RS is congruent to TU, then PQ is congruent to TU. So notice again, they skipped over the blue letters and they just had the red is congruent to the green. Okay, and that's the transitive property, very similar to the law of syllogism. Now, if you think about why they don't have addition properties or subtraction properties, it kind of makes sense. Remember, addition and subtraction can only happen with measurements, but measurements are not allowed to be congruent. So there is no addition property of congruence because you can't add figures together, really. I mean, we can have them being congruent to each other, the same shape and the same size, but we can't actually add them together. If you needed to do addition, you would have to change things into being equal first before you could do that. So the last example we're going to do is one where we have to figure out which property they used in each example. So let's take a look. So in part A, they said angle 1 equals angle 1 in their measurements. The measure of angle 1 equals the measure of angle 1. Notice this is an equal sign, so that means look at the properties of equality and look for the one that says that something equals itself, and that's going to be the answer. So that would be the reflexive property of equality, because that's the property of equality that says that something equals itself. So what you're going to do is you're going to pause the video, try to answer B, C, and D, and then press play to check your answers. Okay, in part B, we see that XY is congruent to VW, and then notice they switched the order. VW is congruent to XY. Now, the one that lets you switch the order from one side of the expression to the other is the symmetric property. And these are congruent symbols, so it's the symmetric property of congruence. In part C, it says angle ABC is congruent to angle ABC. This is something is congruent to itself. So when it's something is congruent to itself, it's reflexive because it's the same thing on both sides. And this is a property of congruence because this is a congruent symbol. Now in the last one, they said angle 1 is congruent to 2 and 2 is congruent to 3. So notice they got rid of all the 2's and they said 1 is congruent to 3. And that's very similar to syllogism. They skipped over the repeated part. So that's the transitive property. And these are congruent symbols. So it's the property of congruence. So that's it for this lesson. Please let me know if you have any questions and don't forget to do your homework.